All right, and now for our last lecture in statics. We don't always get to this point, but since we, doing it online, a little more flexibility with time, so we'll go ahead and do it. Really, it's a review of what we did in physics. We did even harder problems there, which is unusual. Usually we do harder problems in statics, but we are kind of out of time, so we'll do this last section. And we're going to talk about friction. There's lots of types of friction. We're going to talk about dry friction. Examples are, brakes on a bike, brakes on a car. Here's a picture of a guy pulling a refrigerator. And remember that basically there's, friction occurs because of the roughness of the surface, and you categorize the friction between different surfaces by coefficients of friction. But reality is, and we did this little demo in physics, that if I take a block and I pull on it, then I can pull and nothing will happen. But it'll pull back, keep the rope taut, and I can keep increasing how hard I pull until it starts to move. Well, the part where it's not moving we call call static friction, and when it begins to move we call that kinetic friction. And for our purposes there's a sharp cutoff here, and the coefficient of friction during motion, kinetic, is constant, and the coefficient of static friction is has a maximum. We're mainly concerned with static friction here, and so generally when you're doing static friction, you don't know where on this curve you're at unless he tells you you've got impending motion, and that's when then you can make that assumption. So here's a little bit better explanation of it. There's a coefficient of static friction. Notice the force of friction appears primarily on mu and n. The normal force, how hard they're pressed together, and what the two surfaces are like, the material and the roughness, whether it's lubricated, and a lot of different things. But they'll either ask us to solve for that, or they'll give us that in our problems. So typically your right coefficient of static friction is less than or equal to mu sub n. So sometimes you, sometimes you find it from Newton's law. Sometimes you assume that it's at this maximum, but you have to be told that it's impending motion or about to move or something. Inclined plane problems. I didn't really give one on this homework. You might remember those from friction. From physics. There's sort of a list of steps to go through. Do your free body diagram. Assume your direction of friction is opposite to whichever way you would move, which sometimes is a guess. Don't assume this unless you're told it's impending motion, and then you'll just simply apply Newton's laws. So here's a simple case, like the first problem. The uniform crate has a mass of 20 kilograms. If you apply 80 newtons is applied to the crate, determine if it remains in equilibrium if your static friction is 0.3. So what he does is he says, let's do our free body diagram. You got your normal force and your friction. We got our P, 30 degrees, 80 newtons. We also have our weight. So he sums the forces in the X part of that one in friction, and then he sums the forces in the Y. And in summing the forces in the Y, you'll get the normal force. Now here he also takes the moments about, if we know P, which we do, then that's two equations, and that's really all we need. But we could talk about whether or not it's going to tip. In that case, if it was going to tip, then we take the moments about usually the corner. So he solves for the static friction is 69.3. He solves for the normal force. And if you went F is mu times N, and it was, if you went mu times N and it's bigger than F, then you know that it would begin to move. If it's less than F, then you check to see if it's tipping by solving your moment equations and finding. What he does is he finds X, and he says if it's to the left of the center, then it'll tip. If it's not, then it won't. So that's the new thing, is really tipping. Here's another one with a horizontal ladder. You do, again, your normal force and your friction force. And you got a normal force up here too, so they're different. but you simply sum your forces in your X and your Y. He must act to the right. Impending motion. So the impending motion is about to happen. So let's see how he solves this one. He finds our normal forces. Find the angle by determining the sum of the moments. So what was the question on that one? I forgot already. Determine the angle of inclination of the ladder and the normal if it's on the verge of slipping. So he did give us that clue that we can use mu times F. Or F is mu times E. So let's see. He got his N. It would be NB. He got his NB, so then he can go back and use that to get his F. And then he solved, knowing F, he then solves for the angle. All right, so static friction, mu times F. I'll work a homework problem and post it.